For centuries, humanity has looked up at the stars and asked one of the biggest questions ever imagined: are we alone in the universe? Today, that question is no longer just science fiction, zero P. It has become one of the most serious scientific investigations of our time. Thanks to breakthroughs in astrobiology, exoplanet discovery, and deep space telescopes, many scientists now believe that alien life is not just possible, but statistically probable. From hidden oceans on nearby moons to distant planets with life-friendly atmospheres, the evidence is building in ways that are difficult to ignore. In this presentation, we'll explore the scientific reasons why experts increasingly believe that life beyond Earth may already exist somewhere in the cosmos. One of the strongest indicators that alien life may exist comes from the scientific community itself. In a major 2024 survey published in Nature Astronomy, nearly 87% of astrobiologists agreed that basic extraterrestrial life likely exists somewhere in the universe. Even more striking, almost 98% agreed when neutral responses were excluded. That means the overwhelming majority of experts who study the origins of life believe that simple organisms like microbes are likely out there. Some scientists even believe that complex or intelligent life may also exist, although with less certainty. As astrophysicist Mike Garrett explained, most stars appear to have planetary systems, giving life countless opportunities to emerge. This shift reflects a growing scientific consensus. Earth may not be unique at all. To understand why alien life seems likely, consider the sheer size of the universe. The observable universe contains an estimated 106 trillion stars. Plummet 9, that's a number so large it's almost impossible to imagine. Even within our own galaxy, the Milky Way, scientists estimate there may be around 40 billion Earth-sized planets orbiting in habitable zones. These are regions where temperatures could allow liquid water to exist. That's one of the key ingredients for life as we know it. So if Earth formed life under the right conditions, and there are billions of similar planets, the odds strongly suggest that life could have appeared elsewhere too. This idea is reinforced by the Copernican principle, the scientific belief that Earth is not special or uniquely positioned in the cosmos. The search for alien life changed dramatically once astronomers began discovering exoplanets, planets orbiting other stars. To date, scientists have confirmed more than 5,500 exoplanets, and many of them may be capable of supporting life. One of the most exciting discoveries is K2-18b, located about 120 light years away. This planet lies in its star's habitable zone and may be covered by a vast ocean beneath a hydrogen-rich atmosphere. Even more intriguing, the James Webb Space Telescope detected methane, carbon dioxide, and a possible trace of dimethyl sulfide, a molecule that on Earth is only produced by living organisms. While this is not proof of life, it is one of the strongest hints scientists have ever observed beyond our solar system. Life needs ingredients, and the universe appears to be full of them. Scientists have detected carbon, hydrogen, oxygen, and nitrogen across comets, asteroids, and interstellar clouds. These are the essential building blocks of biology. Even amino acids, the molecules that form proteins, have been found inside meteorites that fell to Earth. But perhaps even more surprising is how adaptable life can be. On our own planet, extremophiles survive in conditions once thought impossible. Tiny creatures like tardigrade can endure the vacuum of space, intense radiation, and temperatures near absolute zero. If life can thrive in boiling ocean vents, frozen deserts, and radioactive environments on Earth, then many seemingly hostile worlds may actually be habitable. Some of the most promising places to find alien life may not be distant exoplanets, I state, mind this, but moons in our own solar system. Europa, one of Jupiter's largest moons, hides a vast ocean beneath its icy crust. Scientists believe this ocean may contain more water than all of Earth's oceans combined. Meanwhile, Enceladus has become a prime candidate for life because it actively sprays water vapor into space through giant geysers. NASA's Cassini detected salts, organic compounds, and signs of hydrothermal vents within those plumes. These are the same kinds of environments where life may have first evolved on Earth. That means microbial ecosystems could potentially exist just beneath the ice of these distant moons right now. Mars may be barren today, but billions of years ago, it looked very different. Ancient Mars had rivers, lakes, and possibly even oceans. Its climate was warmer, and it had a thicker atmosphere, conditions that may have supported microbial life. Today, NASA's Perseverance rover is exploring the Jezero crater, an ancient lake bed where sediments may preserve traces of past life. The rover is collecting rock samples that could eventually be returned to Earth for laboratory analysis. At the same time, radar studies suggest there may still be liquid water beneath the Martian South Pole. If true, Mars could potentially host underground microbial life even today. To estimate how many alien civilizations might exist, scientists often use the famous Drake equation. It combines factors such as how many stars form each year, how many have planets, and how many of those planets could support life. Even using conservative estimates, the equation can suggest hundreds or even millions of civilizations in our galaxy alone. So, if life is common, why haven't we seen any evidence? That question is known as the Fermi paradox. Possible explanations include vast distances, civilizations going extinct, or simply the fact that signals may take thousands or millions of years to reach us. The silence of the cosmos may not mean no one is out there. Zero of only that space is unimaginably large. Scientists are no longer just searching for microbes. They are also looking for signs of advanced civilizations. The SLE Institute scans the skies for radio signals that could be artificial in origin. Recent advances in artificial intelligence have made this search far more powerful. Between 2022 and 2024, AI-assisted systems identified several unusual radio signals worthy of further study. Meanwhile, telescopes like the James Webb Space Telescope can analyze distant atmospheres for chemical signatures that may indicate life. Researchers are also searching for technosignatures, evidence of technology, such as artificial lights, industrial pollution, or giant structures built around stars. For the first time in history, humanity has the tools to detect not just life, but intelligence. The coming decades may transform our understanding of life in the universe. In the near future, telescopes may confirm the first reliable biosignatures in exoplanet atmospheres. By 2029, the European Space Agency's aerial mission will study the atmospheres of 1,000 distant worlds. By 2030, NASA's Europa Clipper mission will begin close flybys of Europa, searching for signs of habitability beneath its icy surface. In the 2040s, next-generation observatories may directly image Earth-like planets and study their surfaces. Some scientists predict that by 2075, evidence for alien life may become strong enough to remove all reasonable doubt. The biggest discovery in human history may not be centuries away. It may happen within our lifetime.